Okay, guys, I am so sorry I'm gone again today. I did not intend to be. So I was gone out yesterday for student council, and today my daughter is really sick, so I'm so sorry. So right now it's 8:30 at night, and I'm sitting in our classroom, and it is dark outside, and I'm recording this video for you guys. And I hope it's not too boring. I realize I'm in this room by myself, and so it's going to come out kind of goofy, but just want you to kind of bear with me if you could, because you've got to get this material learned. Some of you guys I won't even see tomorrow because of the Veterans Day assembly, so we kind of have to, we got to move on. We just do. So, and I don't have any of this printed, so this is going to come out really weird, I think, but I'm going to do my very best. So, and I know you guys have probably been working hard on, well, they're not double angle, what are they? Just solving those trig equations, I guess. And I know Ms. Zamor came over and helped some of you guys and left some stuff on the board as well. This is more of the same, except that now we've thrown in double angles and half angles. So, and I know you're probably either, if you did not groan out loud, you probably did in your head. I know that those aren't super fun because the identities are kind of long, but sometimes you can kind of get away with not using the identity, which in this case, for this problem, you're not going to have to use the identity. We're just going to work it out. And actually, hang on, let me grab something. I feel kind of scattered because I'm kind of trying to throw this together and get back to my house. So I apologize. For this one here, this one isn't too bad at all. We can use, now this double angle identity is not too bad. This one actually we do need to use, probably would be helpful. And if you look at your pink sheet, let's see, for cosine, we've got 3 different options here. And I'm going to use this third one. It makes the most sense because I would love it if I could get all of this to be the same trig function. So I'm going to replace cosine of 2x with its identity, which according to your pink sheet says 1 minus 2 sine squared x equals sine of x. And we're just solving for x, which remember, we're looking for an angle. That's what that is right there. What's going to be helpful, I can tell that this is going to be some sort of quadratic. So let's get everything over on the same side of the equation. So I'm going to go ahead and add 2 sine squared x to both sides. And I still have my sine x there. And I'm going to go ahead and subtract 1 from both sides. And this should be factorable. Let's try it, and if not, we're going to have to do that quadratic equation. So let's see here. I'm going to break it apart. I'm going to have 2 sine x here and sine x here. The only way to get 1 is 1 times 1. Positive 2 sine x minus 1 sine x. It's going to give me this positive sine x. So now I've split that into 2 binomials, and so you just break it apart, and you can set those each equal to 0. So we have sine of x equals -1. We think about what angle will get us -1 if we're taking the sine of it. Is that 270 degrees? And I believe that's all that works for that one. For this one over here, it's got, let's see here, we're going to, if we add 1 to both sides and then divide by 2, that's going to give us a half. So you think about what angles will equal a half. And some of you are thinking about your hand trick. Some of you guys are maybe kind of drawing out the triangle, thinking sine is opposite over hypotenuse. That's one of those 1, 2, radical 3 type triangles. And so this must be 30 degrees in there. Now sine is positive in more than one quadrant. It's also positive in the second quadrant. So if this reference angle is 30, then this angle right here must be 150 degrees. Now what I failed to tell you at the very beginning is what interval we're solving for, over what interval. And for this one, we're going to call it 0 to 2 pi. So if it's 0 to 2 pi, you know what, I just realized I kind of skipped the first page of your notes. That's not very fair to you now, is it? Nope, not at all. Man, okay. I'm going to have to start this whole thing over probably. Maybe not. So we're solving 0 to 2 pi. Oh yeah, I don't have to because we just have x. That's fine. Okay, good. We're fine. Let's keep going. Sorry, I kind of panicked. The problem is that we're in degrees, and obviously we need to be in radians, and so we change this to pi over 6. 150 degrees is 5 pi over 6. 270 degrees is 3 pi over 2. And so we have our 3 answers there. So that one worked out fine. We've got a double angle, but we didn't end up having to really use any sort of weird new sort of methods. Now this next one you are going to have to. So let's back up. For me it's backing up anyway, and looking back actually what is the first page of our, what was supposed to be the first page of our notes. Let's see, can I zoom out at all? That is really far in. Okay, let's see here. Let's say it says sine of 3x equals negative 1. It's asking for sine of 3x, and it says that it wants the answers to be in the interval of 0 to 360 degrees. Okay, yes, you could probably break this apart, and you could use some identities, and it would take some time, and it'd be really messy, and some of you guys would quit on me, and some of you guys would just be really hating life. There is another way to do this. If we're looking for sine of 3x equals negative 1, we're solving for an angle here, and we're solving for 3 times that angle, actually. Sine of some angle equals negative 1. Well, you know what angle does that. You know that that angle that gets us negative 1 for sine is going to be 270 degrees. So 270 degrees is 3x. So if we divide by 3, we're going to get 90 degrees. But here's the thing. Here's what makes this problem a little bit different. There is more than one answer is going to get us negative 1 if we triple it within this little interval. And here's how you're going to get it. Think of this right here as x has to be between 0 and 360 degrees. But I'm not really interested in x initially. I'm interested in 3x. If I multiply this by 3, and if I triple this as well, I'm going to get 990, or I'm sorry, 1080. Goodness gracious, 1080. So this is the initial sort of interval for theta, for this 3x that I've got going on here. So rather than just solving between 0 and 360, we're solving between 0 and 1080. So how do we get there? Well, 270 degrees is here, and that's the only way we're going to get sine to be a negative 1. So what about one circle later? So 270 plus 360 is going to put us at, what is that, 630? And then we still haven't made it all the way up to 1080, so let's add one more circle. So if I add another 360 to that, that's going to put us at 990 degrees. Well, that's what theta, or 3x, was that. I don't know why I have a 3 there. That's probably confusing. So 3x equals these 3 different things. If I divide by 3 to get x by itself, then I have 90. Divide by 3, and I'm going to get 210. Divide by 3, and I get 330 degrees. Now, all of those are between 0 and 360. So we're good. These are our 3 answers for that problem. That one was probably confusing. That was our first one, and I don't think I did a great job explaining it. I'm kind of frazzled right now, sorry. Let's go to the next one down, and I think it'll make a little bit more sense. I've got cosine of 2x equals radical 3 over 2. So again, I've got this double angle thing, and you could probably use identities to kind of get you there, but there may be a little bit of a faster way. They want you to solve it for the interval again from 0 to 360 degrees. So I'm thinking, okay, my x needs to be between 0 and 360 degrees. But I've got double this angle. So if I double that angle, I'm going to double these other guys. 2 times 0, 2 times x, and 2 times 360 degrees. So now my 2x needs to fall between these two. So cosine of some angle is going to give us radical 3 over 2. Well, when we think about radical 3 over 2, that angle has to be, let's see, radical 3 over 2 for cosine, that's going to be 30 degrees. And could it be anything else? Well, let's see here, 30. This is a positive. And cosine is positive in the first quadrant, but it's also positive down here in the fourth quadrant. So if this is 30, then it could also be 330 degrees. But remember, we're looking at this interval. 2x can be anything as long as it's between 0 and 720. So let's see here, we need to keep going. So it could have been 30 degrees or a whole circle after that. So 30 plus 360 is 390. And it could have been this 330 right here or a whole circle after that, which is going to put us at, let's see, 330 plus 360 is 690. And then that's as high as we can go on that one because we tap out at 720. But that was double x. So let's divide everybody by 2. That gives us 15 degrees, 150, 165 degrees. Sorry, my brain is not working very fast. I have a lot on my mind. Let's say 195 degrees and 340. Whoops, that's not a 0, that's a degrees. Those are our answers. These answers are half of these original ones we started with. That's how you're going to kind of approach all of these. So those are double angles. Half angles work the exact same way. So I've got, let's see, this time let's do something just slightly different. We have 8 cosine squared of x over 2, there's your half angle, equals 4. And be careful when you see it in your book, it's going to kind of look like this, and some of you guys are going to be tempted to multiply everything by 2. Don't do that. It's the angle is divided by 2, not the entire piece here, so just be really careful. Okay, so I think what we can do here is we can just sort of start to unravel it. Okay, we've got, let's see, if we divide by 8, we're going to get a half. And if we square root both sides, we're going to get positive and negative radical 1 over radical 2. And we square root it, which, if you rationalize that, is radical 2 over 2. So some angle, x over 2, whatever angle divided by 2, this angle, this theta, when we take the cosine of that angle, it's going to equal radical 2 over 2, positive and negative, which is kind of handy because that means every single quadrant. And based on your unit circle, you know that that's 45 degrees. So we have 45 degrees. Here's 45 degrees, here's 45 degrees, and here's 45 degrees. Excuse me. But remember our original interval was that x had to be between 0 and 360 degrees. Well, we have half that is what we're looking for. So we're going to change our interval to half of that. So half of 360 degrees is 180 degrees. This is what we need to stay between. So if that's what we need to stay between, the only angles that stay between 0 and 180 degrees are 45 degrees and 135 degrees. And that's half of the angle. We want to go ahead and double it. We need x by itself to solve for x. So we have 90 degrees and, 270 degrees. And you can always plug it back in and check and make sure that you get the right answer. But that's kind of how you're going to do that. So the first thing you're going to do when you get to these double angle, half angle ones, look and see what your interval is. Take your angle and refix your interval. Go ahead and solve as best you can for the angle within the interval, and then solve for x at the very, very end, the last step. Okay, let's move on. I've got some more examples here that I kind of want you to hit. This one is 2 cosine squared theta minus 2 sine squared theta plus 1 equals 0. And they want you to solve over the interval of 0 to 360 degrees again. Now there are a couple ways that you can approach some of these. You don't have to do them all the same way. let's see here. Let's divide our paper into two options so that you've seen what you can probably do. So you've got option one, method one. Method one when you've got this problem right here. Something we can do is we can try to turn everybody into the same trig function. You know that cosine squared theta based on identities is the same thing as 1 minus sine squared theta. So you can change cosine squared theta into 1 minus sine squared theta. The 2 is still there, and we go ahead and rewrite the rest of the problem. I'll zoom in, and this is super messy because I feel like I'm going fast. Sorry. Go ahead and distribute in, and then we can start to kind of shove things together. So 2 times 1 is 2, and that gets us minus 2 sine squared theta, minus 2 sine squared theta plus 1 equals 0. Putting these two together, we're going to have 2 minus 4 sine squared theta plus 1 equals 0. The 2 and the 1 go together, and they become 3. So I have 3 minus 4 sine squared theta equals 0. Divide, we need to try to get, oh yeah, we can get theta by itself, yeah. Let's subtract 3 from both sides, and I'm also going to divide by -4. Hope that doesn't throw you off too much. Subtract 3 from both sides, so there's a -3 there. We're going to divide by a -4. We wind up with 3/4. And that's sine squared theta. Sorry, let me move this paper up. So I subtracted 3 from both sides and divided by -4 at the same time. Square root of both sides, which means I'm going to have positive and negative radical 3 over radical 4, which is 2. So I have positive and negative radical 3 over 2. Oops, I forgot my sign, sorry. So the sine of some angle is positive and negative radical 3 over 2. And we know if it's positive and negative, that's good news for us. It makes it a little easier. It means that we're going to use all 4 quadrants. Using your hand trick or the unit circle or even triangles. For some of you that might help. We have opposite over hypotenuse. That's one of those 1, 2, radical 3 triangles. This must be 60 degrees. So in the first quadrant, theta could be 60 degrees. In the second quadrant, that's 120 degrees. In the third quadrant, see 180 plus 60 is 240 degrees. And in the last quadrant, it's 300 degrees. So there's all of our possible answers, but something's wrong. I'm forgetting some sort of piece here. Oh wait, did I do it wrong? Sorry, radical 3 over 2. Hang on, I'm forgetting something. Something's wrong. This isn't matching up. Nope, I'm good. I think I was just thinking of the double angles, and that's why it didn't come out double. I think I'm fine. Okay. So we've got our 4 answers right there. Now the other option, and some of you are going to choose this one, and some of you guys caught it right off. You've got this cosine squared theta and this sine squared theta. And I'm thinking with that minus sign in there, if I factor out this 2, that's one of those identities I recognize. This is a little harder for some of you guys to see, but if I factor out a 2, I've got cosine squared theta minus sine squared theta. I still have the plus 1 equals 0. And this right here is an identity. So that's going to be, if you look at your pink sheet, it's cosine of 2 theta. I'm going to go ahead and subtract that 1 from both sides. So that when I subtract that 1 from both sides, I can divide both sides by 2. And cosine of 2 theta equals -1/2. So I'm thinking, okay, what angle, if I take the cosine of it, it's going to give me -1/2. Let's see here. All students take calculus. Well, these two are both positive, so it can't be in either one of those quadrants. It must be here. So let's see, cosine -1/2. This is a radical 3. 1, 2, radical 3. I see that again. This is 60-degree reference angle. And it could also be negative in this quadrant, which is also a 60-degree reference angle. So 2 times theta is 60 degrees, or add another 60 to 180 and we get 240 degrees, but this is that 2 times theta. So your interval is no longer 0 to 360, it's 0 to 720. So I've got to add a whole circle to this and a whole circle to this, which puts me at 480 and 240 plus 360. God, my brain is not working. 600. Take these 4 angles and we're going to cut them in half because that's a 2 times theta. Divide by 2 and now I have 30 degrees, 120 degrees, 240 degrees, and 300 degrees. And if you look at your answers, ding, 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 they match. So again, this one I realized for some of you is a little bit harder to see, but some of you guys may have caught it right off. Up front, it makes your time a little bit more efficient. You're kind of doing less math, but you do kind of have to go back and half them later. So they're both about the same, in length anyway. Okay, I think, do I have one more for y'all? I kind of think I do. Oh, something I do want to make sure that I mention, because some of you may have tried to do this kind of as we were working through it. When you have cosine of 2x equals whatever, I don't know, 2 or something, some of you, a lot of you probably, are going to be tempted to divide everybody by a 2. And you can't do that because the function is not multiplied by 2, just the angle is multiplied by 2. These two are, they're together. That 2 is trapped in there with that angle. You can't divide by a 2. So just be really, really careful on that. I believe I've got one more for you. Okay, so we've got cotangent of 2x minus cosecant of 2x equals 1. So copy that down. And we're going to solve over the interval 0 to 2 pi. And there are a couple of ways to approach this one as well. So I'm going to go ahead and work out both methods for you so that you've seen them. I'd copy them both down if I were you, until you get really comfortable with this and kind of knowing what you prefer. Some of you might look at that and go, oh, well, that's an identity. It's not. In order for that to be an identity, those would have to be squared. And if they were squared, yes, it would be an identity, even though those are both double angles. It doesn't really matter what's there as long as those two match and they're both squared, which they're not squared, so we can't use that identity. But I know that that resembles a Pythagorean identity. Let's see here. One of our options could be, I'm looking at this and I know that's 1 over sine. And I know that this is cosine over sine. So maybe we can do something if we kind of try to put those together. So I'm going to make this cosine of 2x over sine of 2x. And I'm going to make this 1 over sine of 2x. Those are identities. Those are reciprocal functions. You guys are pretty aware of what those things are. And then if I put them together, I have cosine of 2x minus 1 over sine of 2x equals 1. And if I wanted everybody to be in sines, what would be great is we have 3 different identities for cosine of 2x. And you kind of have to be smart about which one you pick. You can't just pick anybody. I mean, you can, but it'll take you a while to work your way through it. Cosine of 2x, if I use this one right here, 1 minus 2 sine squared x, then everybody's going to be in sines, it looks like. It might kind of help me out. So on the top I have 1 minus 2 sine squared x minus 1 all over, let me back over there and kind of get that out of my way, sine of 2x. Which actually, I'm going to go ahead and change this. It's got an identity and it's 2 sine x cosine x. So if I do that, this 1 minus 1, those go away. So I'm left with just this guy that's left. The 2's will cancel. So I have negative sine squared x over sine x cosine of x equals 1. And some of you guys are going to want to go ahead and cancel out a sine, which is legal, but be really careful. I really hesitate to cancel out things that have x's in them because when you cancel out something with an x in it, you might be losing a solution. One might sort of disappear that you might come back and need later. For example, if you have x squared equals x, and you go and you divide both sides by x, you get x equals 1. And you might think that that's the only solution. Well, we also know that 0 also works. So maybe what you should have done on this one is x squared minus x equals 0, factor, and then you'd get both of your answers. You'd get your 0 and your 1. So just know that whenever you start dividing and canceling things out, you might be losing an answer. So you want to be kind of careful on that. If we don't go ahead and cancel this guy out, let's multiply both sides by sine x cosine x. Subtract him from both sides. Or actually, let's make it easy. Let's make everybody positive. Let's add sine squared x to both sides. And we have sort of a quadratic equation going on here because one of them is squared. So let's take sine out of both of them. So we're factoring is what we're doing here. And now you've got two pieces that you can set equal to 0. So sine of x equals 0, which makes x 0. So what angle would produce 0? 0 would. And then cosine of x plus 1, and actually not just 0, 0 and what, pi? Yeah, pi, sorry I missed one. 0 and pi, and then, wait, I feel like I'm doing something wrong here. Wait, I know what we did. Yep, we're going to have to think about this. Hang on. Well, hang on. I'll tell you in a second. Set that equal to 0. So we have cosine of x equals -1. What's going to produce -1? And that's going to be, what, 3 pi over 2? Isn't that 270 degrees? Is that the only thing? Oh, no, wait. Cosine. Sorry. Did I do these backwards? This is the x value. This is the y value. X value to be a -1 would be, they're both pi. Is that okay? This feels weird. I can't get my brain to work. Cosine comma sine, right? Cosine's -1 at pi. What did I miss? Something's wrong. What am I doing? Wait. Did I do that in a weird way? There's a different way to do that. That can't be. Oh, but I'm only getting 2 answers. I'm missing 2 of them. How did I miss that? Did I factor right? Oh no, you guys are going to hate me tomorrow. Shoot. Well, I can say this about this. Let me back up and at least say what I was going to say. This looks like it's sort of a valid answer, and it does produce 0, but we look up here. Sine of x is in the denominator, and you can't have 0 in the denominator. So I can't use either one of those answers, which means that one doesn't work. But I know that this is not no solution because I worked it earlier tonight. So if you type those in your calculator, those are going to come up funky. That's that extra solution I was telling you about, and it doesn't even work. Wait. Oh, did I not factor right? Let's see if I take... Oh, you guys probably caught this, and this whole time you've been watching the video going... You've been watching the video, and you've been knowing what's going on. I'm so sorry. My brain is not working. Okay, cosine of x plus sine x. Sorry, I factored wrong. Is the other one equals 0. If we subtract sine x from both sides, and then watch what happens if I divide both sides by sine of x. And that's kind of tricky. Some of you guys wouldn't have seen to do that. This right here is cotangent. This right here is negative 1. So again, I factored wrong. That should have been sine of x. So it looks like this should equal 0. Subtract sine of x from both sides. If you divide both sides by sine of x, we now have one trig function, which is kind of what we wanted. And on the right-hand side, we have negative 1. So you just have to think where cotangent is negative 1. All students take calculus. So it's negative in the second quadrant and in the fourth quadrant. And if it's negative 1, here I can write it out. If you didn't already know that that reference angle is 45 degrees, you do now. And actually, I think we have to be in radians, so that's pi over 4. This is pi over 4. That would be 3 pi over 4. If this right here is pi over 4, it's going to make this right here 7 pi over 4. So there's your two answers that end up working. And that's one way to work that problem. The other way, and I really don't know if my brain will handle this. Let's think about this. Okay, so here's your original. And the other way we can do it is we can add cosecant 2x to both sides. So let's see here. We have cotangent of 2x equals cosecant of 2x. Oh my gosh, what's wrong with me? Yeah, plus 1. So then our next step is, it would be cool if we could square both sides, because then maybe I'm going to get some sort of identity out of that. So I'm going to have cotangent squared 2x. And if I square this, you have to FOIL it. You can't just square both of those and call it done. So I have cosecant squared of 2x plus 2 cosecant 2x, that's outer and inner together, plus 1. And then I can change cotangent squared to x. That cotangent squared is an identity that will turn it into cosecant. And that's from the beginning of last chapter, right here. If I subtract 1 from both sides, which they do that right here, cotangent squared x equals this. If I have 2x here, I just have to have 2x there. It's the same thing. It doesn't matter. So we're going to use this identity, and we're going to exchange that out for cosecant squared 2x minus 1. And then on the right hand side, is there anything I can put together? No, it's just kind of the same. But now I can put some stuff together. Let's get 0 on the left. So cosecant squared 2x, here's cosecant squared 2x. Subtract, subtract, those are gone. Add 1 to both sides, and that's going to become 2. So now I have 2 cosecant 2x plus 2. So I added 1 to both sides. This 1 became a 2. And then, let's see here. I can take a 2 out, or divide everybody by 2, I guess. I can divide everybody by 2. 0 divided by 2 is 0. This guy divided by 2 is cosecant 2x, and that's a 1. Subtract 1 from both sides. And then we can look at it and say, okay, this is one of those double angles. X is supposed to be between 0 and 2 pi, but everything gets doubled. So now x, 2x, is going to be between 0 and 4 pi. So we need to think of all of the places where cosecant, or 1 over sine, is negative 1. So if we need to do our little deals here, sine and cosecant are negative in the all students take calculus. So it would be sine. Wait, why is my brain not working? Oh, it's wait. Sine's opposite over hypotenuse. This is hypotenuse over opposite. And it's negative. Oh, the triangles don't work. That's why I'm confused. It's a quadrantal. So let's see. Cosine, comma sine. Where is sine negative 1? Down here. Is this the only place? Because if this is 0 comma negative 1, we flip this sign upside down, it's still going to be -1. So that's cosecant as well. So 270 degrees, which is 3 pi over 2. And then, again, we have to look at our interval. Could go to 4 pi, so we've got to go 2 pi beyond that. So 3 pi over 2 plus 2 pi, which some of you guys are not so hot at fractions, but if you made those common denominators, it'd be plus 4 pi over 2, so that's 7 pi over 2. So that's the same, not the same answers we wound up with. Goodness gracious. I'm forgetting something here. Something's not working. Is that 3 pi over 2? Did I even do that right? Guys, I'm so sorry. My brain is just shot. I've had a really crazy, crazy day. Somehow I think this is supposed to match up here. The tops match and the bottoms don't. What did I do wrong? Something's up. Anyway, way to do it. I'll figure it out. I'll teach you guys next Thomas. Most of you aren't going to pick this way anyway. I know you're not. You're probably going to go this direction. You've got a homework assignment, page 285, and you've also got worksheets. That's all going to be due Friday because it is way too much work to do in that amount of time. But a lot of you guys that are watching this video, I'm not going to see you on Wednesday because of Veterans Day. Thursday, I know you're probably going to need some more practice and some more time, and it'll be, for some of you, the first time I've seen you this week because it's just a crazy week. So I want to make sure that we've got that time to kind of work on things together. Hey, thanks for being a great class. Sorry about the crazy video. Be good, and I'll see you later.